Have you ever looked up at the night sky filled with countless stars and wondered, how did our own home, planet Earth, come to be? It's a story that stretches back billions of years, a cosmic saga of dust, gravity, and incredible transformation. Today, we're going to journey back in time, 4.6 billion years to be exact, to witness the birth of our world. Our story begins not with a planet, but with a massive, swirling cloud of gas and dust. Imagine a cosmic nebula, hundreds of light years across, just floating in the vastness of space. This wasn't just any cloud. It was the birthplace of our entire solar system. Something happened to disturb this peaceful cloud, perhaps the shock wave from a nearby exploding star, a supernova. This cosmic nudge caused the cloud to start collapsing in on itself. As the cloud collapsed, it began to spin faster and faster, just like a figure skater pulling in their arms. Most of the material, over 99% of it, got pulled into the center. The pressure and temperature there became so immense that nuclear fusion ignited. Boom! A star was born. Our sun, this young, brilliant star, was the gravitational anchor for everything that would follow. Around the newborn sun, the remaining gas and dust flattened into a massive, rotating disk. Think of it like a giant cosmic pizza spinning around a central light bulb. This was the protoplanetary disk, the raw material for all the planets, including our own. Within this disk, the real planet building began. It was a process called accretion. Tiny dust grains, no bigger than particles of smoke, started sticking together due to static electricity. Little clumps became bigger clumps. These larger clumps, called planetesimals, were like cosmic pebbles ranging from a few feet to a few miles across. Now, with more mass, these planetesimals started to exert a gravitational pull on each other. It was a chaotic, cosmic construction site. Planetesimals collided and merged, growing larger and larger over millions of years. The bigger they got, the more gravity they had, and the more material they could sweep up from the disk. This was a classic case of the rich getting richer. Eventually, these growing bodies became protoplanet objects hundreds of miles in diameter, almost like miniature planets. Our solar system was a crowded and violent place back then, with dozens of these protoplanets orbiting the young sun, all jostling for position. They smashed into each other in giant, world-shattering collisions. Among these brawling protoplanets was the one that would become our Earth. It grew by absorbing smaller planetesimals and other protoplanets that crossed its path. Each collision added more mass and, crucially, more heat. The early Earth was a molten ball of rock, a glowing red-hot sphere with temperatures hot enough to melt any solid material. During this molten phase, a crucial event called differentiation occurred. The heavier elements, like iron and nickel, sank towards the center of the planet due to gravity. This formed Earth's dense metallic core. The lighter materials, like silicate rocks, floated to the top, forming the mantle and the crust. This process is why Earth has its layered structure today: a solid inner core, a liquid outer core, a thick mantle, and a thin crust. It's also what gives us our magnetic field, a protective shield that's vital for life. But the story isn't over. Our Earth wasn't quite the planet we know and love just yet. It was still a target in the cosmic shooting gallery. About 4.5 billion years ago, one of the most significant events in our planet's history took place. A Mars-sized protoplanet, which scientists have named Theia, was on a collision course with the young Earth. The impact was cataclysmic, almost unimaginable in its scale. They struck Earth at a glancing blow, vaporizing itself and a huge chunk of Earth's mantle. A massive cloud of molten rock and debris was blasted into orbit around our planet. For a while, Earth may have had a ring system, like Saturn, but over time, gravity worked its magic again. This ring of debris coalesced, clumped together, and formed our constant companion in the night sky, the Moon. This giant impact hypothesis is the leading theory for the Moon's origin, and it explains why the Moon's composition is so similar to Earth's mantle. The formation of the Moon was a game-changer. Its gravity stabilized Earth's wobble, giving us a more stable climate. It also created strong tides, which may have played a role in stirring the primordial soup where life would eventually begin. After the chaos of the Moon's formation, Earth began to cool down. A solid crust formed on the surface, but it was a volcanic hellscape. Volcanoes were constantly erupting, spewing gases like water vapor, carbon dioxide, and nitrogen into the sky. This was the beginning of our atmosphere, but it was nothing like the air we breathe today. It was a toxic, unbreathable mix. As the planet continued to cool over millions of years, something amazing happened. The water vapor that had been pumped into the atmosphere by volcanoes began to condense. It started to rain, and it didn't just rain for a day or a week. It rained for centuries, a relentless, planet-wide deluge. This great rain filled the basins and craters on Earth's surface, forming the first oceans. Picture it. A young hot planet covered by a global ocean under a thick cloudy sky, constantly bombarded by leftover asteroids and comets from the solar system's formation. This period is known as the Late Heavy Bombardment. These impacts were destructive, but they also delivered key ingredients to the young Earth comets, which are essentially dirty snowballs of ice and rock, likely delivered a significant amount of the water that now fills our oceans. They also may have brought complex organic molecules, the very building blocks of life. And it's here, in these warm, chemical-rich, primordial oceans, that the next chapter of Earth's story begins. About 4 billion years ago, something truly miraculous happened. Simple organic molecules started to combine, forming more complex structures, eventually leading to the first self-replicating molecules. Life had begun. From a swirling cloud of dust and gas to a molten ball of rock, from a violent collision that created our moon to the centuries of rain that formed our oceans. The birth of Earth was a long and dramatic process. It took the perfect combination of chance, physics, and chemistry to create this unique blue marble that we call home. Every mountain, every ocean, every breath of air we take is a result of this incredible 4.6 billion year journey. It's a story written in the rocks beneath our feet and in the stars above our heads. So, next time you look at a simple rock or gaze up at the moon, remember the epic cosmic story of how our planet came to be. Thanks for joining me on this journey through time. If you enjoyed this cosmic story, don't forget to hit that like button. Subscribe for more adventures into the universe and share your thoughts in the comments below. What part of Earth's formation fascinates you the most? Let me know. Until next time, stay curious.